Hello everyone. We will look at the syntax and semantics of the C programming language as part of industry oriented C programming language series. In this session, we will go over the syntactic analysis of the C programming language. We will go over the syntax and semantics of the C language, the details about the compiler of C language, and details about identifiers. Let us see the definition of syntax and semantics. Syntax: the arrangement of words and phrases to create well-formed sentences in a language, or in another way, the structure of statements in a computer language. This is about the syntax. Semantics: the meaning of the word, phrase, or text which is defined in the syntax. This is the syntax notation used in the specification. Like syntax categories, non-terminals are indicated by italic type. Literal words and character set members, which are all terminals, by bold type. So as part of the specification, non-terminals are indicated with italic type, and in case of terminals, which are all it will be character set members, and which will be represented in the bold type in the specification. A column following a non-terminal introduces its definition. So it will place one column after a non-terminal for the definition of that particular non-terminal. So this is the syntax notation. And next one is alternative definitions are listed on separate lines, except when prefaced by the words one of. An optional symbol is indicated by the subscript of opt as an optional in the definition. So for one terminal, non-terminal, there can be a multiple definitions for it. It will be shown as listed as a separate lines, except in case of one of these presented in the definition, so that it is one of the terminals of the in the definition. So you can see in the example in the right side. So it's non-terminal. We are going to define the non-terminal. It is only for the example here. So then we are putting one colon. So this is the definition of the non-terminal, and there are two lines, non-terminal 1 and non-terminal 2, and in the subscript there is a opt. So this non-terminal can have the non-terminal 1 and non-terminal 2 as optional for in the definition of the non-terminal. So this is how this syntax notation looks. We'll see the syntax and semantics examples here. So let us see the left hand side, token. We are defining the token non-terminal with the non-terminals like keyword, identifier, constant, string literal, punctuator. So any one as a token is defined as any one of it, means it can come even the keyword is a token, identifier is a token, constant is a token, string literal, punctuator, and all these things are non-terminals again, because that's why it is shown in the italics. So semantics we'll see for the token. A token is the minimal lexical element of the language in the translation phase of the compiler. So this token, which is defined in the syntactic notation in the left side, is a minimal lexical element. So it means whatever the source code or source file we are giving an input to the compiler. So it will be actually means translated, or it will be decomposed into these tokens. So these tokens is for any one of this non-terminal. So you can see the identifier as a non-terminal. So as part of token, there is a in the definition of token there is an identifier. We'll look at the identifier non-terminal definition here. In the identifier column, we are putting column to define this identifier. It can be an identifier of a non-digit. This is also one non-terminal, or it can be identifier itself. Means it is actually, if you see identifier and identifier, this itself is defining again. Means it can recur multiple times. Means either identifier non-digit or identifier digit can recur any number of times. That's why identifier is mentioned here. So in the definition of the identifier, one of the point is identifier itself. Then identifier non-digit. This is another non-terminal, and identifier itself and the digit. So this is this is the definition of the identifier non-terminal. So you will see here the semantics of the identifier. An identifier is a sequence of non-digit characters and digits. So that's why you can see as part of the identifier token, you will see identifier non-digit and digit as the terminals. So if you see identifier non-digit, again this identifier non-digit is a non-terminal, and it is defined with this non-terminals again. It's a non-digit, universal character name, and other implementation defined characters. So it is any one of this non-terminal. So here other implementation defined characters, it is based on the vendor, like whether it is GCC or a Borland compiler or a turbo compiler. It's implementation defined characters. So finally, if you see non-digit, it is you are seeing one of A, B, C, D, E, F, G, H, all alphabetics in a small case as well as in the uppercase, and lowercase and uppercase. You can see the underscore. So it is one of, this one is comes under a non-digit. So and it is specified as a bold, because in the source file itself it will see any, if any one of the characters seen by the compiler, it will take it as a non-digit. So it will and so that's why it is a terminal. Means it's a concrete thing, it is available in the file. And if you see the definition of the digit non-terminal, it is one of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the definition of the digit. So this is kind of a syntax for identifier. To identify the identifier, it can be combination of these things, because if you see in the identifier non-digit, it can occur multiple times, like A, B, C, then 1, 2, 3, like one identifier. So it's a sequence of non-digit characters and digits. That's how this identifier is defined. We'll see practically later. This is how we need to read the syntax notation and the semantics meaning of it. We'll see one more example of keyword non-terminal. So a keyword is one of these reserved character sequences, like auto, AUTO. If anything in the source file, if you have seen that auto with space separator, then auto is considered as a keyword, and it won't be considered as an identifier, because auto itself is totally a bold characters here. So it should have AUTO, then it is considered as a keyword. So similarly, like BREAK, break, it should come as a break. So in the source file. So all this specific sequence of characters identified as a keyword. So this is the semantics of it. The tokens mentioned for keyword non-terminal or reserved. for use as keywords and shall not be used otherwise. So we should not use these keywords as identifier or any other purpose, because it's a majorly used for the language purpose only. Yeah, we will see how syntactic analysis done by the compiler. So there is a tokenization and parsing. These two are this implicit processes involved in the compiler phase. Compiler phase or the translation phase of the compilation process. So in computer science, lexical analysis, lexing or tokenization is the process of converting a sequence of characters into a sequence of lexical tokens. Yeah, we'll see in the diagrammatically. Yeah, so in the lexical analysis and parser, this generally combined with the parser. These two together analyze the syntax of the programming language. So we'll see. So this we are looking as a compiler phase, means the source file is pre-processed already. So now the file is after pre-processed, the extension of the file is .i. So the source file to this compiler is in the pre-processed one with the .i extension. So this will come. This is an input to this compiler program. So now in this program or in this source file, if the characters are coming like actually this parser invokes the lexer, then it will pass this tree. It means do the lexical analysis on this file. So and this token needs to give back to the parser from the lexer. So this is how it interacts, means it will do the processing of the lex analysis and parsing together. So it's lexer will actually analyze the stream of characters which is coming to that lexer. So it first see I. Okay, I is like a one alphabet, or it is a character, I character. So it can't able to determine, and it needs to look for the next character, then only it will proceed whether to identify that specifically as an identifier or a keyword. So I currently it's only I as one character. So now then it looks for the next character. So in the source file, let us take it is there like I n, then it is n. So there is a now I n. Now so even it can't able to decide whether what it is, because it needs to see the white space, then only it can define it is as an identifier or keyword. So in, then it looks for the next character from this stream. So it takes a t. So now it is int, and it is also not white space. Then it looks for the next character. So next character, let us take it is a white space. Now it is a white space is a separator. Let us take it as a space character. So then it once it sees the space, it will see now int is my character sequence. So then using this int, I will see with my rules or my pattern in the lex. So int is like a token which is of type keyword. So it will identify it as a it will match to the pattern of int as a keyword. Then it will send this token, keyword token, to the parser. So it will then parser, what parser will do, okay, I got a keyword. So then again it will look for the only with the keyword I could not able to see, means what exactly my grammar for it or a syntax, whole syntax. So then again it will invoke the lexer. Okay, I got a keyword, it's fine, but next we need to see what is the next sequence. Next sequence of a token to identify what kind of this line, this total line is. So in that way it will do parsing and lexer will work together, and finally it generates a dot s, means there is a syntactical analysis, then the code generation based on the matching of the grammar rules. So how this is how this token is means generated by the lexer, and it is parsed, or it will be identified with the given tokens with the grammar. With this diagram and analysis, we'll see some of the parsing. Parsing is a process of identifying tokens within a data instance and looking for recognizable patterns. So this is what the parsing. And in parsing, syntax analysis or syntactic analysis is the process of analyzing a string of symbols either in natural language, computer language, or data structures, conforming to the rules of formal grammar. This is another definition of this parsing. So this data structures we can see later. That computer language, anyway currently whatever we are looking is a C language. Natural language, anyway this any language, this parsing and tokenization is important part of it. Then the term parsing comes from the Latin term parse. It's a meaning parts of speech in the Latin. So this lexer is generally combined with a parser, which together analyze the syntax of programming language, web pages, and so forth. So any language, it will do this syntactic analysis. It is together of tokenization, lexicon analysis, and the parsing. Now we'll see unit of program text, or a translation unit. So this, you'll see that the syntax of this translation unit, and you'll see what exactly this translation unit. So translation unit, this is an terminal, and it is defined with the external declaration, and or another one is the translation unit itself. So it means that it can have one more external declaration or one more external declaration, like that. And the external declaration. So it's a totally combination of multiple external declarations. Now we'll see what is the definition of the external declaration. External declaration. This is a non-terminal, and it is defined with the function definition declaration. So any external declaration is either function definition or declaration. So if you see, this translation unit is unit of program text after pre-processing after pre-processing. So whatever that pre-processed output, we saw the phases of compilation process, right? First a source file, then it will be pre-processed, then it will come to the compiler, then assembler, linker, then loader. So here in this case, this one is a unit of program text, translation unit. Translation unit is after pre-processing. So this file is nothing but .i file extension. So here a unit of program text is a C source after completion of the pre-processing stage. From the definition of unit of the program, of this unit of this one source file after pre-processing, what it is getting clear that either declarations or function definitions are possible in the source file. So this function definition or declaration are possible in the C source file after pre-processed ones. Means before even whatever that preprocessor related tokens and directives will be pre-processed, and it comes to a stage where only the tokens which are only handled by the compiler will be available. So this is how function definition or declaration, any one of it will be there in the .i file. So we will see one example how this .c file with empty program or empty lines, and we'll see each one function definition declaration by placing that, so one after the other in the subsequent slides. Yeah, let us take one .c file. I'll just make it as identifiers.c. So it's having nothing, just empty file. There is nothing here. We'll try to compile this file. We'll use the terminal here itself. We'll see new terminal, so that one terminal will be opened here. We'll run this gcc identifiers.c. Just we are compiling everything, like we are thinking it's a program here with empty lines. Just run it, gcc, compile that with the gcc. Now you see there is a error from the ld. So ld is here is a actually it is a linker. If you see in this man ld, it's a GNU linker. So it is actually expecting one definition, like undefined reference to main. Undefined reference to main. So it is actually coming from the scrt1.o that is defined here, this object file. So actually here it is the entry point is start, in that it is expecting this main. Here we actually discussed, right, in that our translation unit, either it should be most possible ones are the declaration or function definition. So majorly I think this main should be either declaration or a definition, but declaration is only a declaration. It won't have any kind of a role in it to continue the set of instructions. So in that way, yeah, it should be it should be a main is like a function definition. So in that way we can confirm that okay, main is our entry point, it is of a type function, it should be a function definition from the our syntactical notation of the translation unit. So main should be a function definition. So now we'll see we just put a main itself, what will happen, and we'll compare. We'll see now we got some error. It is coming from the compilation. So it is error expected equal comma or some ASMR attribute, because main is just a from our lexical and parsing analysis, main is just identifier here, because it's a according to our definition of the tokens, it's not part of any other keyword, and it is having character sequence MAI, and it's part of our lowercase alphabets, and it is not a keyword as well. So in that way the main is just an identifier, but we don't know what kind of identifier it is, but we are expecting a function definition. Main is a function definition. So for this we'll see how this function definition will look as a syntactical notation way. Now we saw that translation unit, how with just empty lines, empty source code, how it behaves, right? Now we'll see the function definition. So this function definition is defined with the syntactical notation like function definition. It is declaration specifiers This is one non-terminal declarator, then declaration list optional, then compound statement, compound hyphen statement and non-terminal. So here declaration hyphen list. So declaration hyphen list, even it is optional here, it is based on the declaration, and it is again the recurring one, declaration list, and then based on the declaration. And here we are actually need to see the declaration specifiers, the declarator, and the declaration list. So it's everything looks like it is again circled back to the declaration, because as a translation unit, either it is a function definition or the declaration. So again, if you see the declaration list, it is we need to know the declaration before defining the function. So here the semantics, the declarator in a function, this function definition specifies the name of the function being defined and the identifiers of its parameters. Okay, we don't have any parameters defined here, and there is a parameter identifiers, and the function itself is also an identifier. So I think we need to see the declarator, declaration, and these parameters, and this what is this compound statement to define a function. For this, we'll first move on to the declaration part. To define the function, we are depending on the declarations, right? So this is a declaration. So declaration syntax is like this: declaration specifiers. If we saw our function definition, here also declaration specifiers are there before this declarator. So even in this case of declaration, it is a declaration specifiers and the init hyphen declaration list. This is optional. These are all the two things which actually constitutes the declaration. Declaration specifiers and init declare hyphen list. Now if you see the declaration specifiers is storage class specifier and declaration specifiers. This is declaration specifiers, again optional, but there is a storage class specifier. Even if you want to define the function, we need to know the declaration specifier. So there is a storage class specifier, is one kind of non-terminal. I think we need to see that one as well, and the type specifier, and then again declaration specifiers, optional. Again this declaration specifier. So it can be a multiple. It can have the storage class specifier, type qualifier, again and again kind of thing. And this type qualifier, and then declaration specifier, optional, and then function specifier and declaration specifiers. This is the definition of the declaration specifiers. So to have this declaration specifier, these four lines also needed. We need to know about it. And there is a init declaration list. Even it is optional, we can see what is init declarator list. Init declarator, this is a non-terminal, again init declarator list. So it can also, this list can have multiple declarators, init declarators. And in this init declarator, definition is having declarator, and the declarator equal to initializer. Either it can have the declarator or declarator equal to initializer. So in the function definition also we are having the declarator. So we need to know this. So this declaration we define now, and it is depending on the declaration specifier and declarator. So we'll see the semantics here. So declaration specifies the interpretation given to each identifier. So it's a declaration is nothing but interpretation given to each identifier. We saw what is identifier, but to identify that there is a declaration required. because so that's why we just kept only one main as an identifier. We are not able to declare, or we are not able to interpret anything from the only that identifier. They do not necessarily reserve storage associated with the identifier. So by just declaring this identifier, there is no storage associated with the identifier. Means there is no storage, in the sense it won't be there available in the final program as a one either as part of the data section or BSS section or the text section as well, a code section we can say. So that is what we identify as a storage. Means that's what in the final program it should be available. So even if you can declare an identifier, in some cases it may not be finally available in the executable program or final output. So the declarations that reserved storage is called a definition. So whenever if we are reserving some storage, that is called a definition of the identifier. So we can have the declaration with the definition together by just using this initializer part here. But actually init declare list is optional here, but if you specify this init declarator list with the initialization, then it becomes like a definition for that identifier. At that time there is a storage required, and it should be available in the final program in one of the sections. So a declaration specifies the interpretation and attributes of set of identifiers. So this declaration specifies interpretation and attributes. So like either what is the storage class specifier, type specifier, type qualifier. So each one is one attribute as part of this declaration specifier. So this one interprets, means this declaration specifies when you one of the storage class specifier, type specifier, and type qualifier or function specifier. So a definition of an identifier is a declaration for that identifier that for an object causes storage to be reserved for that object. So we saw here, right, if it is defined for like a variable or identifier is declared as one integer type of a variable. So this type specifier is int. So and we just given a constant value like a 10. So in that case, that integer value, some x, is an object. It should be there, it should have some storage to it for that object. So object is nothing but one region of space allocated in the storage or reserved in the storage space. So for a function, it includes the function body. So this declaration and definition, it includes in the function body. This we can see later. It is special, a little bit different for the function in case of the declaration and the definition. And there is an enumeration constants, type def name, declaration of the identifier. This enumeration constant is one kind of user defined constant that is there in the language, available in the language. And the type def name, type def is a we can define our own type. For that you can specify with the type def. So there is a type def as a storage class specifier. For the syntactical purpose it is defined. We can see in the later slide. So this is what the declaration. Actually we are not done with that complete declaration part. Most of the things are non-terminals here. So with this declaration part, we will move on to the next declarator. So where exactly this declarator is to identify that identifier, right? So declarator, we'll see the declarator because the declarator is required for the function as well, the function definition as well. So as a part of the declaration, we'll see the declarator. Then we'll move on to all the declaration specifiers, storage class specifier, type specifier. Then we'll see the practical example by editing our source code. Now we'll see declarator. This is the definition of the declarator. Declarator is pointer is optional and the direct declarator. This is the definition of the declarator. So pointer is optional. It is a one non-terminal that we can define later when the pointer concepts, when we are looking into the pointer concepts. But here we will see only majorly direct declarator now. Direct declarator is a non-terminal. It is defined like this. So identifier. So this is the definition of direct declarator. Yeah, direct declarator. Here you can see this definition of the direct declarator. Here identifier, and next one is like rounded bracket, inside it declarator again. So it can have this declarator again, and again this direct declarator. You can see this symbol like a closed bracket. So closed bracket and this type qualifier list assignment expression and that closed right bracket. So this one is actually identification of array. So if anything, if you are seeing in the declarator with this closed bracket left and right, then it is of that identifier of type array. And if you are seeing this rounded bracket like this, direct declarator and this rounded bracket left and right, this is a function. So this direct declarator, it can have a parameter type list with this rounded bracket of function. It can have a parameter type list or direct declarator of an identifier list. It is optional, means it can have only that left bracket, left rounded bracket and right. So this direct declarator is nothing but like identifier. So if we can write like that, right, main and left rounded bracket and right. So in that way we can define this with the main function. And to define the main function, there is some more things required, like declaration specifier also required. We'll see declaration specifier, and there is another thing, compound statement also required to define the function. But this one is like a declarator here, which can be used for declare any kind of identifier. So here the syntax or semantics for it. I am just coming out of this drawing thing. So here each declarator declares one identifier and asserts that when an operand of the same form as the declarator appears in an expression, it designates a function or object with the scope, storage duration and type indicated by the declaration specifiers. So you can see that scope, storage duration, type, these are all part of the declaration specifiers. But here the declarator designates a function or object. So it can be a function or object, means any kind of a storage space or storage region we are using, that we mentioned, they may define it as object. So it can be with the scope. The scope we'll see in the later section, in the document specifier, what is the scope actually. And actually each declarator declares one identifier. This is of an important point here. And the same identifier, it is identified as an object or a function or an array, like that. And this is like a different possible definitions for the direct declarator, and it is direct declarator is a pointer optional or the direct declarator for the declarator definition. We'll see the scope of identifiers. This is one concept defined in the specification. For each different entity that an identifier designates, the identifier is visible, can be used only within a region of program text called it's a scope. So this is the definition of the scope. For each different entity that an identifier designates, the identifier is visible, can be used only within a region of program text called its scope. So for now, our program text is one unit of program text we are calling as a translation unit, under which we can have a declarator as well as a function definition. So by seeing this scope, it can be four kinds. So we can have it in the file itself, like because we saw the translation unit also, right, where is a function definition and declaration. So this identifier itself is possible inside in the file scope. Means if we define or declare an identifier inside the file, we can use in the overall file anywhere. So that is the meaning of the file scope. That is the visibility throughout this file. And next one is the function. So inside the function block or function definition, if you declare an identifier, it will be, the scope will be inside that function. And the next one is a block. If we define or declare an identifier inside the block, so that the scope will be inside that block itself. And there is a function prototype. It is nothing but a function declaration, where we can also declare one parameter with this parameter is also an identifier, right? So we can have a parameter list with one identifier. So it is only if it is declared inside the function, it is only available for the prototype, if it is a function declaration only. Okay, there is right side nothing, it's nothing here. This is what the scope of identifier, which is scope can be of any of these three types: file, function, block, function, prototype. Next we will see the storage lifetime. So we saw that declaration specifiers, out of which one of which is the storage class specifier. So the storage class specifier is any one of it, like type def, extern, static, auto, register. Storage class specifier is a non-terminal. So type def, it is a full-fledged type def needs to come. So it's a kind of a keyword. Extern also keyword, static, auto, register. So this storage class specifier, what it means is, or what it denotes of this object. So the lifetime of an object is the portion of program execution during which storage is guaranteed to be reserved for it. So this is a lifetime of an object, means whether it can be a identifier of type just an object or a variable or a function, an array. So this one, the storage space is guaranteed to be reserved based on the storage class specifier. So if we declare, when we are declaring one identifier with type def, so this type def specifier is only called as storage class specifier, only syntactical convenience. There is no storage mechanism involved for this type def. It is only a syntactical purpose mentioned for the type def. Otherwise it's not much useful for the storage point of view. But if we take this extern is for the external linkage. So currently we are only talking about one unit of program text, right? So that is like it can have a function definition or a declaration, out of which if you declare one extern identifier, it means that it can be defined inside this program unit or in another program unit. So that's why this extern keyword is used to specify this external storage class as an external storage class specifier. So it can be comes from the another program unit as well. So that's why this is extern. But this one, the lifetime is like a throughout the program. The lifetime should be throughout the program. Then only we can link between multiple program units, like translation units. Then next comes the static. So the static storage class specifier also, this lifetime is throughout the program. But this can be internal to one program unit. We can make it internal to one program unit, or we can make it as a even with the multiple program units. So but it is, the lifetime is throughout the program. The storage is reserved for that identifier, which if it is identified with the static. This auto is a default, any identifier which is defined inside a block, that will be taken as a auto. It is actually, the scope is only till that block, whether it is a function block or it's just a block. So this is a auto kind of a storage class specifier. And then a register. So the register, if it is majorly that to identify the identifier and to store it in the register itself. So this register, actually internally some implementations they consider it as an auto identifier. But in some cases this register is like a machine register. So it will identify, give the some register is identified with some different identifier name, but it will allocate one register from the general purpose registers or the register space of that machine. So this is about the storage lifetime, and it is a storage class specifier, which is part of the declaration specifiers, one of the declaration specifier. Then we move on to the type specifier. As part of the declaration specifier, there is a type specifier. So this type specifier is any one of it, void. So if anything comes in that source file like a void with space, so this is a kind of a keyword, and in case of a declaration, it will be identified as a type specifier in the parsing time. So this char, void, char, short, int, long, float, double, signed, unsigned. So this we saw in our previous series of sessions also, like for the data types, like char is for character type, like integer, float for the real numbers, double for the real numbers. So these are all kind of a type or the data type also. And bool, and underscore complex, these are also included as a type specifier. These are all non-terminal, like struct or union specifier, enum specifier, type defining. This is also one type of specifier which can to define another type or another data type. So these three are non-terminals. We can see later for the advanced data types sessions, in the later sessions. So here at least one type specifier shall be given in the declaration specifiers in each declaration. So at least one type specifier shall be given. That's why it's a type C language is statically typed, right? So this is the type specifier. This is what means the type. We need to specify the type of that identifier when it is declared itself. That's why at least one type specifier shall be given in the declaration specifiers in each declaration. So and in each specifier qualifier list, in each struct declaration and type name. Even that specific qualifier list, even these, if we are defining that new things, this while declaring any identifier, this type is required. That's why C is statically typed. So it's a mandatory to declare any identifier by any one of these type specifier. Then comes the type qualifier. This is another type of a non-terminal as part of the declaration specifiers. Here the type qualifier can be a const, a restrict, volatile. So these are all three type qualifiers, which the properties associated with the qualified types are meaningful only for expressions that are L values. So this L values comes into picture when we are discussing about the expressions, like when we are giving some object value to the left hand side, some value, at that time if the identifier which is identified on the left hand side, if it if it is declared as a const type qualifier, then it is not possible to change the value of that identifier itself. We can't able to change the value for that const type of type qualifier for that specific identifier. So this restrict is for the majorly for used for the pointer space, where this pointer is restricted, means we define the pointer, it won't be changed, or it won't be changed later, modified. So that is kind of a one qualifier which is specifically for the pointer, and it is with the blocks also. There is a relation with the block and pointer for the restrict. And then next comes to volatile. This volatile keyword is used. These are all keywords only, and as a qualifier, it is used to tell that compiler that this identifier can be modified by the external systems. Like if it is a machine, right? So when any other interrupt comes or any other uh, external means. So like if you are using, if it is modified by the clock, system clock. So then at that time, when we are reading or when we are using that particular identifier, we should define, when we declare it itself as a volatile, so that the compiler won't optimize that identifier even when we are reading, writing frequently. So it will avoid that optimizations. It will always keep the space for it, or it will always identify the identifier whenever we use it. So these are all like a type qualifiers. We come across that function definition. I think we have not completely defined the function definition, and we saw the declaration and how this declared, and what are the declaration specifiers required for that one, and as well as the declarators where that identifier is declared. Now we'll move on to do some more light on the function definition, which is of that compound statements. We'll just go through the specification itself, see how that compound statement is defined, and then we'll move to the little bit practicals on each that identifier as well as the function definition, by just putting one based on our understanding of today's this session. We will just create some identifier and the function definition. We'll revisit the function definition again once. Declaration specifier, declarator, declaration list, compound statement. We just saw declaration specifiers, declarator, declaration list is nothing but a declaration, again declaration list, and the compound statement. Now we'll see the compound statement, how this syntax for the compound statement looks. Yeah, this is how compound statement looks. Compound statement, non-terminal. It is having this definition like there should be a curly brace, like left side curly brace and right side for the ending of it. Inside this curly braces, there is a block item list optional. This is optional, but it should have a left curly and left and right curly braces. So this is the basic definition of the compound statement. So this block item list can be this block item list and block item. So it's a kind of a recurring one. So this block item list will have block item and a block item. So the block item is for nothing but again the declaration and the statement. So the block item will have the declaration and the statements. So the statements, yeah, we can see what are all the statements possible in the C language in the subsequent sessions by looking at each statement separately. So, and this compound statement is a block. So we saw that scope of the identifier. So one of the kind is a block. So this compound statement is a block statement. Block kind of its a statement is a block. Even the function definition is a compound statement, it is a block. So from here we can actually write a small main, like a simple main, like this one. As part of this function definition, this declaration specifier, declarator, compound statement, we'll go to the declarator and see how we can write this main. Then we'll go to the compound statement. Based on that we can write what we can do. Then declaration specifier. From this declarator we need one identifier, and for the function we need this rounded brackets. So just will like this main and rounded brackets. Then this is for the compound statement that left curly braces. We are not included any declaration specifier. We'll see with this one how it behaves practically. Then we can add based on the compilation error, we can add some declaration specifier. So we will define our main method, our main function with this one only in the source code. Main curly rounded brackets and curly braces. Yeah, now we'll write here main rounded brackets and curly braces. Then save it. And see, we'll compare now. Actually, it is expecting some return type defaults to int. Actually, we have not given any declaration specifier for this function definition. So here it is expecting actually int, return type defaults to int. So we'll just make it like we'll just add our type specifier int here. To add it into type specifier we need a separator, so that's why we'll just put a space, then we'll save it. Yeah, you can see now it is compiled properly. Of course if you run it, it won't give anything because it's only just a main function. It is doing nothing, but it is syntactically everything is perfect as per the C standard, C language definition, but it's not doing much anything here as a functionality wise. Okay, this is the way we defined our function definition. So as part of our translation unit, we just saw that okay, there is a possibility of our declarations as well. So for readability point of view perspective, what we'll do, we'll just add one white space here, new line white space and new line white space. This is the way, and we'll just put one return statement. Of course we don't know much about return statement here, just return. Even just by putting the integer as a return or a declaration specifier, because as a block it is optional to have any statement list, so that's why it has not complained anything. Actually it's actually expected this statement at least, but even if it doesn't have, it has not given any warning if it has a proper int as a type specifier. I will just try, we'll remove this return statement as well. Put the constant int also, we'll see how it behaves. There is no error. We'll make it, instead of int type specifier, we'll make it as void. It does not complain anything. I'll make it int only. Yes, it is a default, is like int, then return 0. Now we'll see that we'll see the identifiers by declaring our case study of the identifiers, and with the different scope, with a little bit more practice in the next session. So for now we are able to define function inside the translation unit. In fact, we can just try declaring another identifier, just a try. So for to declare an identifier, we need to have the declaration, right? So the declaration specifier can be any of this. Just give me a minute, we'll see what is could be the declaration specifiers and how we can put it here. Just we'll give an identifier name. So based on our declarators, we need one identifier, right, to identify it. So we'll just give that our people count, people underscore count as our variable, people underscore count. So this is our identifier, and to declare anything it needs to end with this semicolon as a separator that we can see here. You can see here the declaration. So here you are seeing one semicolon. So for any declaration it needs to end with the semicolon. So here we can specify any one of it, storage class specifier or declaration specifiers. So either declarations put storage class specifier, type specifier, or type qualifier, function specifier. And if you optionally need declarator list also. So that is the declarator equal to initializer. We are not come across much about the initializer. We'll just declare here. So we can see some of the one of the storage class specifier, a type specifier, or a type qualifier by declaring that people underscore count declarator or identifier. So we know that storage class specifier is one of that type def, extern, static, auto, register. Just for our convenience, I will just write down there itself so that it will be easy to see there itself in the code. Yeah, for our convenience I kept all this declaration specifier, storage class specifier, type specifiers, type qualifier, declarator, direct declarator as in the as a comment section, so that it is not part of our compilation process, but in the preprocessing stage itself, this whole comments will get be replaced with the one space. So here we are going to define or declare actually people count, but people count is an identifier. To identify this, so let's go to the declaration. Actually here it's a declaration specifier or any declarator list is optional. Actually to declare anything, actually declaration specifier is enough. So any one of it is enough, but we'll see. We'll just comment this people count for now, because people count is identifier. To identify it, we need to declare. To declare that, we need declare list with the declaration specifier is required. So we'll see only with any of the declaration specifier whether it gives any error or not. So for any declaration specifier, and this one is optional, so we'll just put one semicolon. Just put one of the declaration specifier. Let us take some void itself. We'll take void and semicolon. We'll see what will happen. Void and semicolon. This is a valid syntax according to this declaration specifiers, comma, semicolon. And see what will there it go. Yeah, it is telling this warning, useless type name in empty declaration. So it's, even though it is syntactically correct statement, but it is of no use. It is useless type name empty declaration, which is 53 line number. Where is this 53 line? Here, this void. So it is a, so even if we change it to int, yeah, it is also showing, telling the same useless int here. So then what we'll do, we'll just declare one using this unit declarator list optional one. What we'll do, we'll go to one declarator list. The declarator list can be a declarator init pointer optional declarator direct declarator. We'll go to as simple as possible one direct declarator. Pointer is optional, we don't see now. Direct declarator, so there is a possibility like identifier. So it is a minimum, means if you identify, means identifier is like sequence of some character sequence, then our people underscore count is a proper valid sequence. So we'll just make it as identifier. Then we need the def, any one of it, right? Declaration, storage class specifier, type specifier. We can just try with this int itself here, int, and we'll remove this is user statement. Now we are declaring, not defining, it's only declaration. Declaring people underscore count identifier. This is the declarator part. So declarator, we identified this identifier as a people count, and for declaration we need one declaration specifier, that is int. To use the type specifier here, one of it. Then when semicolon required, we kept one semicolon. Now we'll save it, run it. We'll compile it, not run. Okay, it's working. So it's compiled properly. This is one of the declaration we did. It's good, right? One way. This people count identifier we declared as an integer type specifier with integer. So this people count, we can tell it as a one identifier with of type integer. So according to our translation unit, we defined one function and we declared one identifier of people count. So we made it significant progress of one writing one program unit as a source file. Now just we'll see how these internal files looks like. Save at times identifiers.c. Yeah, it's generated. So if you see here, pre-processing, it's removed all the comments from first line till 51 line number. All that one is removed, and whatever required, it's just added. And here 52nd line identifiers.c, it starts from here. So that is nothing but our int people underscore count constant main return 0, and this is kind of a function definition. This is kind of a declaration of the people count identifier. Now we'll see .s. This is function main. That is our main function. Here size section. This is move, start process, push. Something here. It's actually empty, we are not doing anything. This is the main block, main label. So here this is totally generated by the compiler. So we are actually returning 0. That return value should go from here. This is equivalent to return QRBP Q push. So this looks something strange, right? We will see in our later sessions what it means, how we can read it in detail way. Now we'll disassemble this object file obj dump -d identifiers.o. Okay, now this is actually object file. Here we can see this is main section text, main push RBP, pushing some base pointer, RSP stack pointer, base pointer. Base pointer is moving to stack pointer and moving 0x0 value to AX. Then pop RBP red Q. So it's written. So there should be some meaning for this thing to tell. Here it's only returning, but there should be a mechanism that value 0 should be returned to who called this main. So okay, yeah, this return 0 means we can see from the bash shell, right? Shell, like after executing that program, whatever the returning value it is returning, we can see with the echo $?. If you want, we can change it and see returning some other value, and we'll see how it looks. We'll return 1. Save it. Save temps. We'll see how. Yeah, it changed here value. So it is giving some 1 value here into AX, and then it is returning. Even we'll see the object dump. This is object dump. Now we'll see there is 0x1. It is moved to AX. Here it is 0x0. Previously we were returning 0. Now we are returning 1. Program here. Our object file is changed. Now we'll run and see it out. Then we'll just see echo $? This is anyhow, it is bash related, shell related bash shell. Now you can see returned 1 because we executed from here, from this shell. It is actually returned the bash 1. It has executed the data.out from here, and it has returned that whatever that returned from our application program. So we are returning 1 here. So this is how we saw identifiers, definition of it, declarations. Then in the next sessions we'll go a little bit deep into some more practicals of these identifiers with a little bit more combinations, how the storage class specifier, type specifier behaves, and with some constants, and we'll try to print an output to the screen like what we did in the hello world. For that also we'll go to little bit about the function definition or function calling. For now we'll for today or for this session we'll make it till this point, like we defined one function, we declared one identifier. Yeah, then we'll see our stats. 50% is the syntactic analysis part of any language design. This is hypothetical number, like for any language design, syntactic analysis is a major part. 50% at least goes there only. And then translation, I missed n. Yeah, this translation unit, this is the one point we are going to take away from here. Final point: function definitions and declarations are present in a unit program of text after pre-processing stage. That's what the translation unit. Then this is one quote from Jan Carmack: I would rather have a search engine or a compiler on a deserted island than a game. This is one quote. So this is one takeaway: compiler based, statically typed and procedural. So that is what we saw today in the session. Compiler based, so we analyze syntactical analysis, how this compiler is behaving for the C programming language compiler. And statically typed, like what is the type specifier, what is the importance of the type specifier when declaring any identifier. Then procedural paradigm, like function, we saw the function definition, which is actually that it's only allowing that in that majorly that is allowing this function definition or the function procedure and one type type to it, and it is giving a compiler error if it is not available or if it is syntactically incorrect. So this is compiler based. So these 3 points or 3 paradigms what we saw in the introduction session we proved in this session. So thank you.